Mathematical modeling. This is sort of like pre-mathematical modeling because recursive sequences is an introduction to the topic. Recursive sequences are used a lot in mathematical modeling, so we need to know a bit about them first. Here's an example of a recursive sequence. Notice that two terms are used to get the next term. Yes, that is the Fibonacci sequence, a Fibonacci sequence. It is recursive because it depends on the previous terms to obtain the next one. So, each term of the sequence is defined as a function of the preceding terms. It could be term or terms. Recursion, the process of choosing a starting point, note that's important, and repeatedly applying the same process to each term to arrive at the following term, or applying the process to each two terms, three terms. It requires you know the value of the term immediately before the term that you're trying to find, and that means to get the second term you're going to have to be given the first term. So there are two parts to a recursive formula: the starting value, term 1, A1, and then the recursion equation, which gives the next term in terms of the previous term or terms. It could be an minus 1, but some will write an plus 1 and then an. Here's an example. Recursive sequence described by the formula a1 equals 4, so it gives us a starting point, and then an equals twice an minus 1. Now that's twice the previous term. This is pretty obvious to many what this is going to be, but it's not always as obvious, so let's start with the simple ones. So each time we're doubling the term to get the next one. And if we have a look at this, we'll see, well, first of all, by inspecting, no. Common first difference, no. Geometric, are we multiplying by the same thing each time, or is that over that equal to that over that equal to that over that? Yes, so it's a geometric sequence, common ratio 2. So therefore Tn equals 2 to the n plus 1. There's the recursive formula as given. And then we have this algebraic formula, which we refer to as an explicit formula. As an example, there we have a sequence defined by recursive formula. And you're asked to give the first 4 terms, so it's a case of substituting, and then determine an explicit formula for the sequence, and that would be done by using these first 4 terms. So, take each term, starting at 2, and add 6. Add 6. And add 6. Now to find the explicit formula, I always suggest people that go through a pattern first see if it has a common first difference. If not, then have a look to see if it's geometric with a common ratio. And if not, then look for a common second difference. Now, if you look at this, if you add on 6, add on 6, add on 6, there we are. That is a common first difference. So therefore, it is a linear sequence or an arithmetic sequence. So therefore, common difference of 6, and for each change in 6, if 1 for n, it's changing 6 in value, therefore it's going to have 6n, so Tn equals 6n plus some number. And we can substitute term number 1 being 2 into the formula to find that something. So Tn equals 6n minus 4. Here are some examples to try. Pause and try them yourself first before going through the answers. Number 1. We're multiplying by 3 each time. Start at 5, then multiply each term by 3 to get the next term. We can probably see, but let's go through the process. First difference, no, because that's 10, then that's 30. Common ratio, 3, 3, 3. Yes, common ratio of 3. Therefore, it's a geometric sequence. Tn equals 5 times 3 to the n minus 1. Number 2, starting at -4 and keep adding 4. Common difference of 4, so it is a linear sequence, arithmetic sequence. This next one's now a bit more obscure because we're adding the number of the term to the actual previous term. So you'll see that it starts getting a bit more obscure and more difficult just to predict what the sequence is. We get to a stage that we have some really complex recursive sequences in mathematical modeling depending on number of terms and what has happened. So in this case we're going to take 1 and then we're going to add twice 2. We're going to add that answer plus twice 3. So if we have a look at this one. First term, 1. Second term, 1 plus twice 2. Third term, 5 plus twice 3. Fourth term, 11 plus twice 4. Let's look to see if we can find the explicit formula. First difference, 4, 6, 8, no. Common ratio, no. Second difference, 4, 6, 8 is first, second, 2, 2. Yes, it has a common second difference, so that makes it a quadratic sequence. Tn equals an squared plus bn plus c. And there is the sequence.